Yes. So I just want to give a real quick introduction to a very important tool or technique that we'll be using a lot in this class. I'll ask you to make a lot of models. Okay? A lot of the activities will be make a model of this, make a model of that. I love models. They're efficient, they're effective, they're a great tool for demonstrating understanding on an individual level. Okay? And so when I ask you to make a model, what I'm asking for is a straightforward, visual-based, simple representation of a complex idea. And so it's basically taking something that would take like 2 or 3 pages of writing, and I'm asking you to show it to me in one little blurb of expression. Right? And now, very often what these will look like are drawings, right? Most of your models will probably be some sort of drawing. It is not an illustration. It does not need to be accurate, right? You do not need to be a good artist to be making good models. And in counter to that, you could be a terrific artist. You could draw a beautiful thing, and it could be an absolutely abhorrent, horrendous, disgusting model, right? And so the model, in order to be effective, needs to represent the main ideas, and it needs to do so clearly and quickly. A lot of times, as we move forward into life, models become mathematical in nature. Right? And so occasionally in this class, you might be able to make a mathematical model. And so here I have a few different types of models or examples of models, some model models for exponential growth, right? And that's a growth pattern that follows exponential maths, right? So it's not 2 plus 2 plus 2 plus 2. It's 2 times 2 times 2 times 2 times 2. So like 2 to the 8th, that's exponential, right? So the graph looks like that instead of linear. Okay? And so this thing right here, 2 to 4, 4 to 8, 8 to 16, that's a model. That's a model of exponential growth. That's simple, right? Straightforward. 2 organisms become 4, 4 organisms become 8, 8 organisms become 16, right? 16 would become 32. That's one way to model exponential growth. Another way to model exponential growth would be a graph, right? Graphs are models of data. You show me a graph, that's a model, cool. All right? And then a third way, and not by any means the last way to do a model, would be a little illustration, right? So these are my little bugs. I started with 2 bugs, they became 4 bugs, they became 8 bugs, become 16 bugs, become 32 bugs. Right? These are all effective, good models of the same idea. Okay? If we look down here, this is a good model, a decent model of pizza. Okay? Doesn't look anything like pizza. It looks a little bit like pizza. I made it round. Okay? I could have made it a star shape. I could have made it a square shape. I could have took a picture of my face. And that could still be a model of pizza, as long as the important information inherent to what makes pizza is represented. Right? And so there's a carb base. Right? So I got my dough, I cook it, pizza pie, base in the carb. Now you can make a cauliflower pizza, right? And then is a cauliflower pizza really pizza? I mean, I have to call it a cauliflower pizza for a reason, right? Up for debate, right? But in this model, I'm saying that pizza needs to be carb-based. That's what makes it delicious, all right? Then there's cheese topping. Almost all pizzas that I've encountered have cheese topping. Every once in a while, you don't have a cheese, you have something else, and that's okay. But for the most part, you get cheese topping. There's a sauce layer, right? Otherwise, it's just bread. If there's no sauce, it's just bread. And that's not a pizza. It's delicious. All the pizzas are delicious. Hawaiian pizza is delicious. Shrimp scampi pizza is delicious. Cheese pizza is delicious. They're all pizza, and they're all delicious. Okay? So that's a model of pizza. Perfectly good. Over here, this rectangle is a model of a dog. Beautiful model of a dog. It has all the dog properties that dogs have. Right? So there's fur. I've labeled it as fur. There's 4 paws because dogs, when not missing or gaining extra paws, have 4 paws. It has a tail, right? Sharp teeth because they're carnivorous, and they got 2 ears. Right? And so that's a model of a dog. Perfectly good. Okay. So not about illustrating stuff properly. It's not about making accurate illustrations. It's about representing the inherent traits of the thing, right? The traits of the thing that are pertinent to whatever it is that you're trying to display have to be apparent, and they should be apparent like that. And that's a good motto, okay? That's it. Bye.